Okay, welcome back everybody. Today we're going to look at absolute value equations. So this is the beginning of Unit 6. Now, if you can solve the radical equations from the last video, then these ones should go fairly smoothly, I think. Okay? Alright, so let's start out with what an absolute value is. What is the definition of an absolute value? Well, we just say the absolute value of A, okay, and we use the vertical bars to denote the absolute value. The absolute value of A is the distance A is away from the origin. The distance A is away from the origin. On the real number line. Okay, or that's to say how far away it is from 0 on the real number line. Okay, so for example, the absolute value of 3 equals 3. Since 3 is 3 units away from 0. Okay, so if we do a diagram on the real number line, it just looks like this. Okay, well, of course, negative infinity's down here, positive infinity's down there somewhere, 0's right smack dab in the middle, and then let's say that we're 1, 2, 3, let's say 3's right there. Well, you can see that 3 has a distance of 3 units. Okay, it's got a distance of 3 units from 0. Okay, all right, so one more quick example. The absolute value of minus 2 is equal to 2. Okay, and this is for the same reason. If I'm on the real number line, let's say 0's right about here, then I go in the negative direction twice, or 2 units. Minus 2 would be approximately there, and you can see that's a distance of 2. Okay, all right, so we want to solve absolute value equations here, so maybe let's just start with a very easy, simple example, and hopefully it will help you build your understanding of what's going on here. All right, so let's solve the following equation. Let's solve the absolute value of x equals 5. Okay, now the idea here is I just want to do this by inspection. So can you see the two numbers that satisfy this equation? Well, if I put in 5, what's going to happen here? Well, maybe I'll just do this off to the side. If I put in 5 for x, I get the absolute value of 5, which of course is 5. So x equals 5 is a solution. And then if I put in minus 5, well, the absolute value of minus 5 is 5. Therefore, x equals plus or minus 5. Those are the solutions to this equation. Okay, now, in general, how we're going to solve these equations, and I think I'll just start with another example, actually, or just do another example. But basically, the idea is to isolate the absolute value, okay, and then set the inside equal to plus or minus the outside. All right, so let's give this a shot. Let's make it slightly more difficult, but not too much more difficult. let's solve the absolute value of x plus 1 equals 2. Okay, well, I mean, here's the idea here. What do we need to happen here? Well, I need to get the absolute value of 2, because that equals 2. And I need to get the absolute value of minus 2 on the inside, because the absolute value of minus 2 is 2. So what am I going to do here? Well, just by inspection, I can see that if x equals 1, I'll have a solution. And if x equals minus 3, I'll get minus 3 plus 1 is minus 2. And then that will solve the equation as well, or that will be a solution to the equation, I should say. Okay, so let's try this out. So all you need to do is set the inside equal to plus or minus the outside. And that's because I want the inside to equal plus 2 and minus 2. Okay, so I'm just going to say x plus 1 equals plus or minus 2. Okay, now at this point, I'm just going to solve for x, just like I would with a normal linear equation. I'm just going to subtract 1 from both sides. And it might look a little bit weird, but I could say x equals plus or minus 2 minus 1 like that. And now we've got two cases, okay? I've got case 1, let's call it x1, a little bit out of space here, I'll squeeze it in here. Okay, so x1, let's say, our first solution is plus 2 minus 1, and of course that equals 1, so that's one of our solutions. And then my other solution, x2, is minus 2 minus 1, and that equals minus 3, so that's my other solution here. Okay, now observe what happens when I put in 1. When I put 1 back in, I get 1 plus 1 is 2, and the absolute value of 2 is 2, so that was that case there. And then when I put in minus 3, I get minus 3 plus 1 is minus 2, so that's that case there. Okay, so again, I just want to get the inside here equal to plus or minus the outside. And those will give me the solutions to this equation. Okay. All right, so in general, they're fairly easy to solve. Okay, the recipe's just the same for solving radical equations. Okay, we're just going to isolate the absolute value, but instead of squaring or cubing both sides, for these, we're just going to set the inside equal to plus or minus the outside. Okay. All right, so let's just quickly write that down. Okay, so to solve, we're just going to, isolate the absolute value. And then 2, set the inside equal to plus or minus the outside. And that's it. Okay. All right, so let's try. Okay, let's solve the absolute value of x minus 2 minus 1 equals 5. Okay, so it's fairly straightforward, you know, just like with the radical equations. If I asked you to isolate this, this is essentially like solving a linear equation. To isolate the absolute value here, I would just plus 1 to both sides. Okay, it'd be the same as solving this following equation for y. Y minus 1 equals 5, and then you just plus 1, which would give you y equals 6. Okay, all right, so to isolate, I'm just going to plus 1 to both sides, like so, and that gives me the absolute value of x minus 2 equals 6. Yeah, I'm just going to swap out my pen here. This one seems to smudge. I imagine this one's going to have the same issue, but we'll give it a shot. Okay, now at this point, all we need to do is set the inside equal to plus or minus the outside. Okay, so set the inside equal to plus or minus the outside and solve for x. Okay, so what does that give me? That gives me x minus 2 equals plus or minus 6, like so. And then I just isolate x here. That's essentially a linear equation. And just add 2 to both sides. Let's just write that off to the side. So I'm going to plus 2 to both sides, which gives me this. X equals plus or minus 6 plus 2. And now you can just break it into your two cases. Just break it into your two cases. So let's do it like this. I can say x1 equals plus 6 plus 2. And then I can say x2 equals minus 6 plus 2. And then if you solve these, hopefully you can do this in your head. This just says x1 equals 8. 6 plus 2 is 8. And x2 minus 6 plus 2 is minus 4. And these are the solutions. Okay? All right, so I'm going to run another quick example for you here. So, I mean, I guess if you tried doing exactly what I said to do, set the inside equal to plus or minus the outside, you might run into some extraneous roots here, but I'm just going to give you a heads up on when you don't need to solve these or when there are no solutions, okay? So let's look at this quick example. All right, let's solve the absolute value of x equals minus 3. Well, I mean, just play with this in your head for a bit. Are there any values of x that are going to satisfy this equation? Well, what do we know about the absolute value? Well, we know that an absolute value is a distance, i.e. it's always a positive number. Therefore, no matter what value of x I stick in here, it's always going to evaluate to a positive number, but here we've got a negative 3 on the outside, so in this case, this equation has no solutions. Okay, so this equation, this is not solvable. Okay, so if you ever are solving an absolute value equation and you have the absolute value of something equals a negative number, just say, nope, this is not solvable. Okay, so this is not solvable. Since an absolute value cannot evaluate to a negative number. To a negative number. Okay. All right. Let's do 2 more examples. Okay, we'll do 2 more examples here, and then I'll give you guys some homework to do. And if you want to pause the video as soon as I get this example down and try to solve it for yourself, it might be a good idea. I think they're pretty straightforward. Let's try this. Let's solve 3 times the absolute value of 2x plus 4 minus 2 equals 7. Actually, let's do equals 10. Sorry. We might get fractions here. I'm hoping by doing 10 instead of 7 we'll avoid fractions altogether. Okay, let's give this a shot. Okay. You know, I just solved this in my head. I believe x equals 0 is the solution, but that's okay. We can still solve it. Okay. All right. So the main point here is I'm trying to figure out, or I just wanted to show you guys how to isolate the absolute value here. Okay. All right. So if I isolate this, what would I need to do here? What would I need to do to isolate the absolute value here? Well, you can kind of just think of it as isolating y for this equation. I'll just do it up here again. If I'm trying to isolate y for this equation, what would I do? Well, I would just add 2 and then divide by 3, right? Okay, so if I do that here, it's the exact same thing to isolate the absolute value here. I'm just going to plus 2 and then divide by 3. Okay, so I'm just going to plus 2, and that gives me 3 times the absolute value of 2x plus 4. Sorry, I really dislike writing with these pens. Oh, my penmanship is terrible here. Criticism accepted. Okay, anyhow, if I add 2 to both sides, for those of you that aren't in my class, you should see me write on the board. It's quite beautiful. I think, personally. It's taken some practice, but it's quite nice. Okay, so I've plus 2 to both sides, which has given me 3 times the absolute value of 2x plus 4 equals 12. And now if I did that up here, I'd plus 2 and then I would divide by 3. Same thing here. I'm just going to divide both sides by 3. Like that. And now those 3's cancel, and I'm just left with the absolute value of 2x plus 4 equals 12 divided by 3, which is 4. Okay, and now at this point we want to set the inside equal to plus or minus the outside. So we get 2x plus 4 equals plus or minus 4 like that. Okay, and now we should isolate x here. We should isolate x. And so again, just think of it as a linear equation. The first thing I'm going to do is just subtract 4 from both sides. And that leaves me with 2x equals plus or minus 4, minus 4 like that, and then I'm just going to divide both sides by 2. I'll just write that there. I'm going to divide both sides by 2. And if I do that, the 2's cancel on the left side, and I'm just left with x equals plus or minus 4, minus 4 divided by 2. And now we can set up our 2 solutions. And what are my 2 solutions? Well, I can say that my first solution, x1, equals 4, for the plus 4 case, 4 minus 4 divided by 2. And then my second solution, my x2 is equal to minus 4 minus 4 divided by 2. And then hopefully you can see here, 4 minus 4 is 0. 0 divided by 2 is 0. So x1 equals 0. That's one of my solutions. Okay, and then x2 is minus 4 is minus 8. Divided by 2 is minus 4. So those are my two solutions. Okay, good. That actually worked out pretty well. For some reason in my head I said, oh, well, if x equals 0, sometimes when you solve these equations you get the same root twice. So, well, maybe not. But I thought, maybe that would happen with x equals 0. So anyways, we got two solutions, so that's great. Okay, I'm going to do one more quick example here. It's kind of a bit above where we need to be, but not by much. It's fairly straightforward, and if you're trying the homework questions, you might get stuck on this type. So I'm going to do one more quick example here. So for example, let's solve the absolute value. So let's do 2 times the absolute value of y minus 1 equals the absolute value of y minus 1 plus 4. Okay, if I try to solve this here, well, how are you going to isolate the absolute value here in this case? Well, really, again, if I were just to ask you to solve this following equation for w, 2w equals w plus 4, what's the first thing you would do here? Well, in this case, you would just minus w from both sides, okay? So what I can do is I can just subtract that to that side. Okay, so if I do that, I get this, 2 times the absolute value of y minus 1, and then I'm subtracting the absolute value of y minus 1, and then this equals plus 4 like that. Okay, now at this point, what would that look like in this step here if I did that? Well, it'd look like this. I'd do 2w, subtract w to the left-hand side, which would give me that, and then we would collect like terms. Okay, so we didn't have a chance to do this in the radical equations part of the course this year because we needed to shorten the curriculum a bit, but I figured, you should be able to see that these are like terms going into the next course, okay? So, what do I have here? I've got 2 apples minus 1 apple. How many apples do we have? We've got 1 apple left over. Or in other words, 2w minus w. It's essentially the same thing. Okay, I've got 2 objects here minus 1 of the same object. I'm left with 1 of them altogether. So I'm just left with the absolute value of y minus 1 equals 4 like that. Okay, and then I think this is kind of child's play from here on out, I think. Okay, so again, we'll just do our two cases. We have y minus 1, sorry, it's a bit premature with that arrow there. Y minus 1 equals plus or minus 4, and then we can do our two cases. My y1 equals, okay, sorry, let's start that over again. Sorry, I got a bit ahead of myself there. I'm going to isolate y here, so again, I just set the inside equal to plus or minus the outside. So I'm just going to plus 1, And right about now, I'm really not enjoying making this video, but hopefully it's okay. All right, so what do we get? I just get y equals plus or minus 4 plus 1. Okay, and now we can finally do our two cases. So I get y equals 4 plus 1. Let's call that y1, which equals 5. And then I've got my y2 is equal to minus 4 plus 1, which is minus 3. And those are the two solutions. Okay, good. It seems like I'm falling apart a bit here, so we'll call it quits on this video. I'm just going to assign you homework here, so if you want to do for homework, let's do pages 400 to 402. Like so. Okay, then you should be nice and ready to move on to the next topic. And we just have a couple topics left to go here, so just keep pressing forward, and I'll see you for the next video. Bye for now.